Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the molar heat capacity of a monoatomic non-metallic solid at 298 Kelvin, which is characterized by an Einstein temperature of 2000 Kelvin. Express your result as a multiple of 3R. So the first thing you have to note is that this is a quantum chemistry question from the Atkins Physical Chemistry 11th edition textbook, and it is from chapter 7, which is the quantum mechanics portion of the textbook. So we're going to reread this question and we're going to write out like the information and the parameters so we can start solving. So we were told to calculate the molar heat capacity of a monoatomic non-metallic solid. So CV would be, I'm going to call it CV comma M because we're dealing with molar heat capacity. And processes like this, when you study your textbook, you're going to note that it occurs at constant volume. So that's where we're having CV comma M. So molar heat capacity at constant volume, and that's what we're supposed to calculate it. So that's the unknown. Um, this occurs at 298 Kelvin. So we have a temperature of 298 Kelvin, which is characterized by an Einstein temperature of 2000 Kelvin. So an Einstein temperature will be theta sub E, which is just 2000 Kelvin. Express your result as a multiple of 3R. Now you're going to be wondering, okay, how do I solve this question? Well, it's actually very straightforward because there is the formula in the textbook, and the formula for solving the molar heat capacity for a question like this, when you're given the temperature and Einstein temperature, is just simply CV comma M is equal to 3R, R meaning the gas constant that we know to be 8.3145 joule per mole Kelvin. Okay, so that will be 3R, and then you also have F sub E of T. Now, remember they said you express your results as a multiple of 3R. We're not going to do anything with the knowledge of 3R here. We're just going to leave it. We're not going to multiply it to this particular value. So you have F of E sub T is what we're going to be solving for, and then we're just going to attach it to 3R as the molar heat capacity. So yeah, that is it. Now, I want to quickly mention this. F sub E of T is actually equal to this formula right here. It is theta sub E, so the Einstein temperature, divided by T raised to the power of 2, so squared, multiplied by E to the theta sub E divided by 2T divided by E to the theta sub E divided by T minus 1 all squared. So this is basically this. So this is basically the formula that we're going to use. And as you can see, we have our value for theta already given to us and our value for t. And in all the other questions, we have all of the values. Of course, we know what E is. E is just a constant 2.7, whatever. That's just basically the value for E. So every single information we need to substitute into this equation has been given to us. So we can start the calculation. So F sub E of t, okay, when we substitute theta sub E, that would just simply be 2000 Kelvin divided by 298 Kelvin all squared multiplied by e to the theta sub e to the theta sub e, so that will be e to the 2000 Kelvin divided by 298 Kelvin. So divided by the bigger division, e to the theta sub e, so e to again 2000 Kelvin divided by t. Oh yeah, sorry, not just divided by t. When we go back here, I apologize. It is not divided by t, it's divided by 2t. So divided by 2 times 298 Kelvin. So let me rewrite that. Divided by 2 times 298 Kelvin. So, and then here at the bottom, we have e to the theta sub e divided by t. So that would be e to the raised to the power of 2000 Kelvin divided by 298 Kelvin minus 1 raised to the power of 2. F sub E of t is going to equal, you're going to cancel out the Kelvin here and then cancel out this one here. So when you cancel out, of course, when you do this question, you can, what they call it, we can actually do fractions or you can do decimals just for the purpose of us using our calculator and not like wasting time. I'm just going to put in my calculator 2000 divided by 298 Kelvin. And when I do that, I end up with 6.71141, then all squared. Then multiply by e to the 2000 Kelvin divided by 2 divided by 298. So that's going to simply be e raised to the power of, when you do 2000, you can just simply cancel out the kelvins. First of all, you're going to cancel out 2 from 2000, so that will make you 1000 right here. So when you have 1000 right here, so you have 1000 divided by 298 Kelvin. You end up with 3.3 e to raised to the power of 1000 divided by 298 would just be 3.3557 divided by e raised to the power of, cancel out this. So e raised to the power of 6.7114. 6.71141. So minus 1, and all of this all squared. So of course, we do what we know how to do best. We're going to input this information in our calculator. So let's change the marker. So f sub e would be, or f sub e of t would be 6.71141. All squared is simply 45.043. And then e to the raised to the power of 3.35570 will simply be 28.6657. Okay, divided by e raised to the power of 6.71141. That's just going to be 821.720. Okay, so that's this one here. Then, of course, let's not forget our very beautiful minus 1. Yeah, and all of this information all squared. So f sub e of t is going to equal 45.043 divided by 28.6657 divided by 820.720, all squared. And of course, when we put this information in our calculator, just this part, which is just 28.66572 divided by 820.720, all squared, is going to simply give us 0.0012197. And then f sub e of t is equal to 45.043. So all you have to simply do is multiply. So f sub e of t is equal to 45.043 times 0.0012197. You end up with 0.054951110. So that's basically the value. F sub e would be 0.054951110. So yeah, that is how you solve it. But let's not also forget that we're dealing with a question, and the best thing we have to do is to put it in the proper number of sig figs. And because of course it's a chemistry question, we will go back to our work and see the lowest number of sig figs. We see from our question that we have 298 Kelvin as one of the values, which is 3 significant figures. And then we also see we have 2000 Kelvin, which is also 3 significant figures. So we have to put it, sorry, which is 4 significant figures. And we usually pick the lowest number of significant figures. So we're going to put our answer in 3 sig figs. And when we do that, we end up with f sub e of t is going to equal 0.054951110. 550, because of course there's this one here, so we have to do the, what's that thing called again? We have to like do the approximation. We have to round up. Now we're gonna be thinking, okay, we've done f sub e, so now we can put it back into the equation. Let's rewrite the equation. We know that it is the molar heat capacity that we're told to solve for, which is basically what the question asks in the first place, is 3r f sub e of t. So that's 3r is equal to 3r f sub e of t. We already know what f sub e of t is. So normally we're just going to think, oh, we're just going to say 3 times 8.3145 times f of e sub t. But remember, the question says express your result as a multiple of 3r. So all we're just going to simply do is our final answer becomes cv comma m of t is equal to 3r 0.0550 or 0.05503r. So this is basically the answer to this question. We can write it both ways, it doesn't really matter. So this is the answer to the question. So if you have any question, right, put in the comment section. If you have any questions or concerns, also put it in the comment section, the suggestions, concerns, question, put it all in comment section. I also wanted to mention that if you're a student who is struggling in any of your STEM related courses, or you're just a student who wants to improve or and be the best version of yourself in academia, I help STEM students succeed in all their STEM related courses, whether they're in middle school, high school, or college. So if you like STEM tutoring from me, make sure you email me at shabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.